Anyway, today Michele's going to talk to us about structural design patterns.
Thank you. Here's the title of this chat, as you see. Let's move on. So, just a short digression and explanation about what are design patterns. So, this is just a quote from Wikipedia, which I think contains all the things that I've ever heard about the definition of what a software pattern is, more or less. And I would say that I would add something up about that. So basically, Wikipedia talks about it as a solution to a problem, to a recurring problem, and of course, this is somehow very broad. What does it mean? I mean, it can be a very big problem or a smaller problem. And so the last sentence of the quote actually, in my opinion, clarifies this. Between paradigm and a complete algorithm. So it's lays in dimension. Let's say it's between two extremes. I would say that calling design patterns a solution or calling them solutions is not always true, in the sense that there's been some criticism of some patterns. Some patterns can actually be the wrong solutions to problems. So what I think that is to my experience and to my view, the best way to use patterns. I think that something that cannot be discussed. That is not debatable to me is the fact that they basically are named for concepts that can be potentially useful, and this allows people to discuss about this. So knowing them allows people to have meaningful discussions about how to implement and how to design software from a higher point of view. Okay, so there are different types of design patterns. So in the context of object-oriented programming, I think that the book that I'm going to use mostly in this talk talks about three different types: creational, structural, and behavioral. And more in general, I think that there are many variants of the idea. So for bigger, if you talk about designing an application or designing systems, then you talk more about architectural design patterns, and there are also some patterns related to how do you treat concurrency, how you treat multiple processes and their communications. So that's it for what I know, and so in this chat I'm going to talk about the structural ones, just because I wanted to touch some, and I think that creational ones are quite easy and possibly there's not too much to discuss about this. Structural tend to be somehow interesting, but also quite short, and behavioral instead are actually a bit broader. I think that structural was a good topic. Okay, so according to that book, which is a book from 1994, and is still considered one of the Bibles of the subject, there are 7 structural design patterns which have these names, and if you compare, if you look at on Wikipedia, there are some others, or other textbooks actually don't mention, for example, flyweight. For some new books, in some new books it's not mentioned. So I'm going through all of this more or less briefly, and just to so let's give some meaning to these names. So, adapter. It just does what it says on the tin, basically. So the intent is that you basically have, the solution is that you have you have an interface, okay, a class or an object that behaves in a way that is not compatible with what you would like it to, with the way you would like it to work, to present its structure or its method. So, well, basically you write an adapter for this. And now, there are, in the literature, patterns are usually described in this way. So first there's the title, the name of the pattern, then there's the intent, and then there's a description of the structure of the pattern, and the collaboration between the participants to the pattern, and some other considerations like the pros and cons of that pattern, the consequences, etc. Here, I try to summarize very much. Next, for each pattern, there's also a UML diagram, okay, which shows basically what I'm talking about. And in this case, well, so here is the UML diagram for the adapter pattern. So just a bit of notation. So these arrows, the empty arrows, mean that basically this adapter, okay, is a kind of target, okay, in the sense of inheritance. So it's this class, this adapter class, extends both this and this. Okay, is that the full arrows denotes in general has that for example this line has a target. Okay, this is more or less the meaning of the arrows. And yeah, so here we're talking about the class adapter. Okay. Which means that we have an adaptee, which is the class that we want to adapt, okay, and a target, okay, and we would like to be able to adapt more things to that. And so the client would like to interact with a target, okay, but we don't have a target, we have just this that needs to be adapted, and so we create this adapter. Yeah. There's also another version, which is the one with the object adapter, where basically this the right part of the diagram is changed into basically an object, and this arrow here is not an is a, but it becomes an as a. So basically, this adapter owning an object, which is the adapter, which is not a class. This is quite simple, I think. Okay. But I mean, just to give name to this concept, I think it was just worth mentioning. Of course, this is my perspective, and I mean, I'm not particularly seasoned software architect. So if you read books, you can find tens of pages about how to, what are the possible implications using adapters, etc. So, yeah. I mean, from my point of view, I mean, I can't add any more, anything more to this, but maybe it's worth a reading if you have any need. So, another pattern is the so-called bridge. I'm going through this in alphabetical order, just because what the book does. So the intent of bridge is to basically, it's decouple an abstraction from its implementation so that the two can vary independently. Basically, I mean, more in general, I think, the idea is to have two groups of classes, two hierarchies of classes, okay, and make so that changes I mean, of course, this is already a solution. So sometimes you would like to have some, and you are in such a situation, okay, which is possibly a realistic situation, okay. So we have the original design is like we have windows and we have two subclasses which implement the window on different window systems, for example. Yeah. Now we want to subclass window, okay? Creating a new class, which is the so-called icon window. Okay. Now, if we want to subclass it, I mean, to keep the same philosophy that we have here, okay, but doing this transformation in our design, we need to also, create two more classes for the icon window, one for the X window system and one for this other window system. And this is not particularly nice, as you see. So a possible solution to this problem and to this ugly situation is the following. So we define our windows, our kind of windows, okay, in this way. So we define, I mean, here just to be clear, these are in italics, okay. The name which are in italics actually represent interfaces or abstract classes, okay. When instead the straight ones, which are not in italic, represent proper classes, okay. And so here as well, this triangle here represents implementation. So like the empty triangles that I was using the previous Uml diagram. Okay. And as you see, we have decoupled the implementation with the just to remember what is the intent. Okay. So yeah, we have an abstraction and the implementation, and here you have the window, which these are the abstractions, and here is we have the implementations. And you can see that it's possible to have. The idea here is to be able to have an icon window created on different systems. Okay, so I think I can go on and show the UML diagram. Okay, which is somehow simple. Yeah. More in general, I would say that I've heard also of the bridge design patterns as a way to basically couple loosely two different class hierarchies. Here is a class hierarchy, and this is another class hierarchy, and you basically connect these two hierarchies by this operation, and well, this is the abstract operation, and that's instead the implementation of the operations. Okay, so let's move on. Another design pattern, which is actually the first design pattern that I ever came up with myself, and then I found out that it was actually a design pattern, is this composite. So, this is a pretty good definition of the intent, I think. Basically, the idea is to compose objects into three structures, so that basically individual objects and the composition of objects can be treated uniformly without, in uniform. Okay, and I would say, let's go to the example. Okay, I think that in general, a good example of this has to do with the graphical elements or with drawing. So basically, a picture here can contain a line or a rectangle, for example, but also another picture inside, okay, which can contain text, line, and so And in general, the composite pattern allows you to treat this kind of trees in this way. So we have a composite object which contains leaves, but also can contain composite objects. Yeah, this picture has come from that Bible that I said before. So the UML diagram. Actually, there's a line missing here. So basically, there's an abstract class, or abstract class, I would say, or an interface, which is this I component. I use I to specify that something is an interface or an abstract class, because I can't use the italic here if I try to write in italic. People won't understand. So, yeah. And here I have two classes that implement this, okay, that extend it, yeah. And one is the leaf, which is the concrete object, and here instead the other is the composite, which instead can be a composition of. You see here that, I mean, these are the implementation arrows, and this is a possession. I mean, this is and you can see here that there's a ball here, which means that the composite can actually contain more components. I think that in modern UML diagrams you see that with an asterisk instead. This is somehow, this notation comes from the 90s, before UML was created. Okay, slightly similar to this, but only with only one component. Okay, so without this ball here, is the decorator pattern. Okay, and the decorator pattern actually has quite another intent. Okay, but the UML diagram will be quite similar instead. Okay, so the idea here is to attach additional responsibilities to an object dynamically, and the important bit here is that this is a design pattern that allows designers to basically to avoid the so-called class explosion. Okay? And I can show you an example for that. When you, I mean, the problem with the subclassing is that you may end up having, if you want to use only subclasses, you may end up having a very large number of them. Okay? And decorators allow a possible solution to this problem. I can show you an example. Okay. Okay. So let's say that we have a visual component which is like a window. Okay, and we would like to add to this window a scroll bar. Maybe not a vertical scroll bar, a horizontal scroll bar, or some border, some different borders, etc. Now, if we want to create different classes for a window without scroll bars, a window with one scroll bar, windows with two scroll bars, a window with scroll bar and a border, I mean, you see that we can actually end up with a lot of subclasses. So the decorator, basically, the decorator pattern solves this problem. And in this way, basically, using composition instead of inheritance. Okay? Because composition is basically when a class contains as a member another object instead of inheriting or extending. So basically, yeah, this is the decorator. okay, which is in this case it's an interface, which is implemented by these two possible configurations, and the decorator itself is a visual component. Okay? So it can be treated as a visual component, as the composite was able to be treated as a component. Yeah? But it also has a visual contains a visual component in this inside, and of course this is not. We need a leaf kind of object or class, which in this diagram is represented by text. Okay. So basically, with this kind of classes, I need to have a text view, okay? Yeah, and then I can apply to this text view as many decorators and scroll decorators as I want, basically. Yeah, so I can create a sort of a stack of decorators on top of an object, which will be the text. This is actually, I think that it's quite related to decorators in Python or in Python, in JavaScript as well. Because for function decorators, for example, you define a decorator as basically second order function, and you then apply this decorator to this second order function to any function, and you get another function, which is the decorated function, which actually behaves exactly as a visual as the base class. Okay, so UML. I'm just copying the other diagram, just replacing names. I think I already described everything here. Yeah, the thing, of course, that I want to point out is that this decorator actually add some behavior or some state to the component that they decorate. Another thing, another pattern that, well, it wasn't the list, but to me it's quite underwhelming. And actually, I just read that it becomes invisible if you use modules. Basically, is the so-called facade. Possibly worth knowing the terminology, but basically, well, when you have a complicated subsystem, a very complicated system, and you want to just show some elements or a simplified interface to that subsystem, you create a facade. I don't know if there's anything more clever associated with that. I think we can move on. Yeah. Then flyweight. I think that it would be nice actually to move directly to an example, because to me this flyweight is somehow, I actually don't. It's a bit mysterious to me. So here you see that the intent is to use, basically the idea is to be able to use objects even in situations where it would be very costly. An example of this is, for example, in text processing or in text editor. We may want to treat each character as an object, okay? But the same character usually share with all the other characters in the same class. So, for example, all the A's have all the lowercase a, for example. May actually have the same properties. Yeah. So the state related to those objects actually can be shared. Okay. And in this way, using sharing, we can reduce a lot the footprint of our object. So, well, can I show you the example maybe? No, I have no example. Well, the example is actually written here. So, yeah, I was talking about text editors, and so there's the important thing is that we need to be able to store the state of our objects to divide it into two parts: the intrinsic state, okay, which in this case is just a single character, okay, and an extrinsic state, which is the position of the character in the document, and, for example, the font that is used. I don't know. I found it interesting, but I don't know how people use it actually. People make use of this kind of things.
Actually implemented Upload in scientific code.
Okay, well, it would be interesting to.
The interesting thing is I have to double check what I actually did, but basically it was some sort of lower order or higher order conceptual storage for graphs in graph theory in like a standardized way so that I could fetch them quickly from a subsystem that used them.
Mm-hmm. Okay. So I will move to the last one. Yeah, so the proxy. Yeah. So I think that everybody has an idea of what a proxy is. I would say that I would like to remark that there are some flavors of proxy. Okay, so these are the variations that I have seen mentioned in different books. So remote proxies, which provide a local representative for an object which is in a different address space. For example, if it's on another server. Okay, and I've also heard that this was called ambassador in some literature. A virtual proxy that is actually the one which is talked about in the book that I'm using to explain these things, which is basically. Possible virtual proxy is the use of a virtual proxy could be this one. Basically, talking always about text processing and typesetting. When the book that I refer to was written, it was in the 90s, and in the 90s, actually, processing text was still possibly very expensive, and images were actually pretty heavy to do. So they suggest in the design they suggested basically they were using proxies for images, okay? And the proxy for an image would just be a box, basically represent a box with a just height and width, okay? And this proxy would have a method which would be render, okay, which would be called lazily. So only when actually the real image had to be displayed. Okay. So the idea is that in this way you can have as many proxy images as you want in your text, without having paying the cost of rendering them every time you render the text. So there are also other examples that you read there. Also, futures can be considered as proxies. So here is a simple UML diagram for proxies. You have the proxy object, which is a method, request method, which will call the request on the real subject, and both of them are actually an extension or an implementation of subject class or subject class. Okay. So these are just some caveats that I think that may be worth mentioning. Different sources, so different textbooks, different articles, different people give different classifications and of patterns, and also identify different variations of flavors and types of patterns. Then given pattern can have different usefulness in different languages, and this actually relates very well to what actually is written in this. This is a link to a presentation by this guy, Peter Nagri, which shows, for example, that 23 of the patterns which were described in the famous book I'm constantly talking about, that out of those 23, 16 can be made redundant in a language like Lisp. Okay. So this makes the idea of those design patterns a bit not well defined, in the sense that if it's a solution of a problem, well, it's not a solution it's a solution that depends on the language, and this somehow makes it a bit confuses a bit what pattern is with what an idiom is. Which, as far as I understand, idioms are basically patterns, but which are deeply connected to the language you are using. For example, there's a book about idioms in C++, and which basically have no, maybe in some other languages with the generic programming, they may be applied. But well, I mean, if the language has no generics, then there's no way to apply those idioms there. And also patterns can be used in appropriate ways, I think. And they are not a substitute for good design principles. And it would be nice to discuss a bit about possible good frameworks, philosophies, and design principles. Because in that, well, I mean, good design principle should somehow guide to the use of good patterns, the good use of patterns, but patterns themselves cannot. And after this, the last slide is second covered as this quote by this guy, which I think could be interesting. So basically, like, it basically says that there are different levels of mistakes. I think that at my stage, I can still make mistakes with building the wrong algorithm, and also I think that after this, I'm going to also use the wrong patterns. So yeah, we'll see. Anyway, so thank you for your attention, and I hope we can discuss